So for 2.4, day 1, our goal is going to be to write linear equations that model real-world data. Slope-intercept form is what we've been talking about, y equals mx plus b. Our last lesson was just direct variation, which ignores the b value because it is just y equals mx or y equals kx. Today we're going to be adding that y-intercept back in. So the first thing that we have two different types of examples. When you are working with story problems and writing a linear equation, either your example, the first example, what it's going to give you is a slope and either your starting point or some point, or it might just give you 2 points like we're going to do in example 2. So we want to be able to figure out how to identify if a slope is given. So if we are given a slope, your m value, okay, that's going to be your rate. Now, if you see per, like PER, or like here you're going to say miles per hour, really how this is written is miles over hours. So as soon as you see something like that where it's miles per hour or revolutions per minute or something like that, that is typically going to be your slope. Because your rate is actually found, your slope is found by your rise, your change in y over your change in x, your rate is going to be the units of y over the units of x. Okay? So this example here, so your slope actually will tell you what your units of your y-axis are going to be and what the units of your x-axis are going to be. So if we read this, it says, I have no idea where the O went in my slope, but if we read this, it says Hunter gets on the highway in Fowlerville traveling, it's supposed to be 68 miles per hour. Write an equation to represent the distance from Fowlerville after X hours. Okay? So miles per hour, that tells you that when you go to draw your graph, when you draw your graph, you have your x coordinate and your y coordinates. Okay? So based on our, not really sure what happened again to that 8, but based on the fact that we were going 68 miles per hour, miles is the top. When you're doing rise over run, the y's is your rise, so that means that our y-axis is actually being measured in miles. So when I label my y-axis, I am measuring it in miles. Well, what are you measuring if you're measuring miles? You're measuring distance. So when we go to do this problem, we have to start by defining the variables. So we need to say what x equals and what y equals. So my x equals my y equals the distance, and it's measured in miles. And that's how we write when we define variables. We have to say, what is it we're measuring? We're measuring distance. How are we measuring it? Goes in parentheses, miles. Okay, so the x, that's on the bottom. So hours. What does hours measure? Hours measure time. So x is going to be your time measured in hours. So down here we will label time, and that's measured in hours. Okay. It says write an equation to represent the distance from Fowlerville after X hours. Now, we already know that that is going to be the slope, so our equation is going to be y equals 68x plus, what is our y-intercept here? Well, in this case, our y-intercept is going to be 0 because at the starting point, his distance from Fowlerville is going to be 0. At time 0, he's getting on the expressway in Fowlerville, gets on the highway in Fowlerville, so he's actually at 0. So we do not even need a y-intercept there. So it's y equals 68x. Let's figure out how far Hunter will be after 10 hours. Okay, now the reason why it says approximately, it is not asking you to randomly guess. There is room for human error. So the idea is that this equation is not going to always be 100% accurate. I'm sure at some point someone braked in front of Hunter and he had to slow down, or maybe he had to speed up for some reason. Either way, 68 is an average, okay? So it's not going to represent exact what this trip looks like. So when we say after 10 hours, approximately how far is Hunter traveling, it's not saying to guess. It's saying use this equation that represents the real world where there could be human error. So what we're going to do is we are going to plug this in. Y equals 68. 10 hours goes in for X. So we plug in 10. We get that Y is 680 miles. Okay. We should graph this, and when we graph it, we already labeled our axes. We should have a title. We always need a title on our graph. The way that we title it is Y versus X. So distance versus time is how we should label our graph. That should be our title. Okay, so I went ahead and put scales on here. My scale on the time was going up by halves, so 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. And my Y scale was going up by 50, so 50 I labeled 100, I didn't label 150, I labeled 200, so on and so forth, all the way up to 700 there. All right, so then I can start putting the points on my graph. Now, you can just use a calculator. You can always make a table. So maybe you want to make a table over here for your X values, Y values, 0, 1, 2, 3, 4, 5, 6. Plug them in. And when we use a calculator to plug those in, 0 times 68 is going to be 0. 1 times 68 is going to be 68. Times that by 2, you're going to get 136. 3 times 68 will be 204. 4 times 68 is going to be 272. 5 times 68 is 340. 6 times 68 is going to be 408. So now that we have these points, we just have to go ahead and plot them on my graph. 0, 0. 168. 2, 136. Oops. 3 is just above 200. 4 is at 272. And then you can kind of see this should be going in a straight line, because when we graph linear equations, we should be able to connect them from a straight edge or with a straight edge. 340, 408. Once you have all your points on your graph, you're going to connect it with a straight edge. So I connected it with my straight edge, and this was what my graph looked like. Now notice I may have made a little bit of errors, or maybe my straight edge. I should make it look so that all those lines or all those points fall on that line, but doing it on an iPad is a little bit difficult. So let's go to the next, or let's actually interpret what the X and Y intercepts would be. The X and Y intercepts, I can plug those in because I know that when I'm finding my X intercept, I know that it's at X comma 0. If I'm finding a Y intercept, it's 0 comma Y. Now, in this case, they're actually the same thing, because if I plug in 0 for X, I actually get 0, 0. Well, that's also then an X intercept. So the origin, 0, 0, okay, which is this point right here, that is going to be both your X and your Y intercept. So if we're asked to interpret this, all we're going to do is we're going to write a sentence with that intercept. So at time 0, or at 0 hours, Hunter has traveled 0 miles. So at time 0, he's traveled 0 miles. That's all it's asking, is take that those intercepts, write it as a point, and then make sense with it. Now, in some cases, we'll actually have 2 of these. So thought I was using a pointer. So if, let's say, in a completely different situation, let's say we had 2 intercepts, and this was like 210, and nope, just kidding, intercepts. So 2, 0, and 0, 10. Okay, so if X is still representing time and Y is still representing distance, it would say at 2 hours, Hunter traveled 0 miles. Down here it would say at time 0, Hunter is 10 miles away from Fowlerville. So that's how you would interpret something like this if there was a difference between the x-intercept and the y-intercept. But in our case, we only had the one intercept because they were the exact same. So next problem here, example 2. Here we go. Now, as I said, sometimes it'll give you the slope and a point. That's what it did in example 1. Sometimes it will give you 2 points. So this example on the back is one where it gives you 2 points. Okay, so let's fill in our blanks here. So it says Audrey burns a candle. After 90 minutes, the candle was 8 inches tall. And after 3 hours, the candle is 6 inches tall. Write an equation to represent the height of the candle after X hours. Okay, so the first thing that we're going to do is we're going to define our variables because we always have to start with defining your variables. And what's nice about the assignment for this is I literally broke it down. So part A says define your variables, so you'll know exactly what to do first. So in this case, X equals Y equals. X is going to be, it says after X hours, so I know it's being measured in hours, so X is going to be our time in hours. So what does the Y value represent then? Y is going to be, write an equation to represent the height of the candle. So Y is going to be the height of the candle. And how are we going to measure it? We'll measure it in inches because that's the 2 measurements that it gave us. We're both in inches. Now there is one problem with this. One of the points that it gave us was not using hours and inches. It says after 90 minutes, the candle was 8 inches tall. So that point right there is not 90 minutes. 90 minutes is not allowed. So what is 90 minutes in terms of hours? 90 minutes is 1.5 hours. So that's what we're going to have to use. But we're trying to come up with the point. So X is actually going to be 1.5 and your Y is going to be 8. So that's the point from that data. This next piece of data says after 3 hours, it's 6 inches tall. So that's in hours and inches. So this point is 3/6. Okay. So we have our 2 points here. 1.5 comma 8 and 3 comma 6. We first have to find the slope. Okay, so y2 minus y1 over x2 minus x1. So my y's go first, 8 minus 6 over 1.5 minus 3. 2 over negative 1.5. Oh, well, you can either put that in your calculator and change it to a fraction, or you could think about 1.5 is the same as 3/2. So you're doing 2 divided by 3/2. To divide a fraction, it's keep, change, flip. So keep, change, flip, and that's going to be 4/3. So we just had to do a little bit of side work. Negative 4/3, sorry, because you're dividing by that negative. So your slope is going to be negative 4/3. So that's that part of it. Now, we are trying to write an equation. So we have a slope and we have 2 points. Okay? But more than likely, it's asking for the equation in slope-intercept form. Meaning what I'm trying to get to is y equals mx plus b. Right now I have m. So right now I have y equals negative 4/3 x, but I'm still missing that b part. So what I need to do is I'm going to have to find that b. So there's 2 different ways you could do this. You could take a point that you know and plug it in for x and y and solve for b. That would be one option. Or you can write it in point-slope form and convert it to slope-intercept form. So I'll show you both ways. So we will do the plugging in the x and the y first. So plugging in the x and the y first, it doesn't matter which point you would use. I would probably pick the 3/6 point because they're whole numbers. So I have 6 equals negative 4/3 times 3, plus the b is what's unknown. 6 equals negative 4. If I multiply by 3 and divide by 3, it goes away, plus b. I'm going to add 4 to both sides. I'm going to 10 equals b. So now I can rewrite my equation now that I know b. So my equation is y equals negative 4/3 x plus 10, because I found that b was 10. So that's one way to do it. The other way to do it is to write it in point slope form, which is the y minus y1 equals m times the quantity of x minus x1. You can choose which way you like better. It does not matter to me. Okay. Plug in the slope and one of the points. Again, you can choose which point you use. I would probably use the 3, 6 point. So I'd have y minus 6 equals, my slope was negative 4/3 times x minus 3. Then what you're going to have to do is you're going to have to get rid of those parentheses, so distribute. Negative 4/3 times negative 3 is going to be a positive 4. You're still looking at getting that x alone, so what you're going to do is add 6 on both sides. And if you notice, you get the exact same equation that you had right there. So it does not matter if you decide to take a point, plug it in, and then find b, or use point slope form, plug in the point and the slope you know, and convert it. Either way, you're going to get your slope intercept form to be y equals negative 4/3 x plus 10. So then we're going to go to graphing that equation. So I have my x-axis and my y-axis on my graph. I'm going to label them. I need some scales on my graph. Now the candle, I can see that it was at some point 8 inches tall, at some point it was 6 inches tall. If you recognize your y-intercept here is going to be at 10, I want to make sure that my scale goes up at least to 10. So I'm going to go up by ones here. So I'm not going to label 1, I'll label 2, I'll label 4. And now I'm going to plot the points that I know, okay? Or you can use the equation. It doesn't matter how you get this graph. It just, if it's asking for a graph, we have to get it somehow. So a couple things you could do. You could plot the 0, 10, because that's your y-intercept based on your slope-intercept form. You could then go down 4, right 3. So when we go down 4, you can count down 4 here, but you can't count over 3 because you actually only went over 1.5. So you have to count over 1, 2, 3 using the scale from our x-axis. So right there is down 4, right 3. Do the same thing again. And then connect it with that straight edge. Now, you might even recognize that you could find some points in between there, because on my graph, what it's actually looking like it's doing is it's going down 4, right 6. So if I just go down to right 3, I could add some more points in there, which is the exact same thing. So 2, right 3. So that's a point right in the middle. That's a point right in the middle. So you can add more points if it's possible. Now, you don't have to do that, but it's just a one way to put more points on it. It makes it a little bit easier to graph. Okay, so I went ahead, I connected those points. Here's my line. And then it says, when will the candle burn out? Okay, so the candle will burn out. What would you know happens when the candle burns out? that's when the height reaches 0, okay? So if you know that the height is going to be 0, the height, which is your y, based on how we defined our variables up here, okay? So your height, which is your y, is 0 inches. That's when the candle will run out, okay? So what we can do is we can plug in the variable that we know. Since we know y equals 0 at that point in time, we're going to plug that into our equation. So we have 0 equals -4/3. We're trying to find the time. And the reason I know that I don't know x is because it says when. So that right there tells me I'm trying to find x. So that means when I'm saying when will the candle burn out, since I'm looking for the time, that means somewhere in there, within that sentence, it told me the height of the candle. So then you have to think about it. What would the height of the candle be if it burns out? The height of the candle will be 0. So you plug it into the equation, and now what we will do is we will solve the equation. So the time is going to be 15 halves, but that's actually going to be 7.5 hours or 7 hours and 30 minutes. Don't mistake that for 7 hours, 5 minutes or 7 hours, 50 minutes. It's 7.5, and 0.5 of an hour is actually 30 minutes. So 7 hours and 30 minutes, that's when that candle is going to run out. Now, if it was asking you to interpret the x and the y intercepts here, this is actually going to be, we just found that point at 7.5, 0. So what I would do, I can go through and I can mark that right here. But if I was asked to interpret this one, I would say at 7.5 hours, the height of the candle will be 0, or the candle will burn out. Okay. Here I would say before the candle starts burning, or at the start of burning the candle, so when you first light the candle, the initial height of the candle was 10 inches tall. So you're just interpreting, ooh, and I made a huge mistake on my graph here. I forgot to label my axes. So we should go back, and on your axes, your x-axis represented time in hours, and your y was your height in inches. And then your title on your graph would be height versus time. Okay. So that would be the complete problem for number 2. We would have written the equation, we graphed it, we interpreted the intercepts, and other than that, that should help you. Like I said, there are 2 types of problems. If you just want to put a little side note on here, those 2 types of problems that you can look for. Example 1 gave you the slope, and it's going to give you some kind of point. Our point in example 1 on this set of notes was 0, 0. It was the origin, but it doesn't have to be the origin. In example 2, it gave us 2 points. So when you are reading your problems on your assignment, you need to ask, is it giving me 2 points, or is it giving me a slope? And if it's giving you a slope, there's got to be another point in there it gave you. So hopefully that will help, and have a good